Good morning, everyone. My name is James Sierra A. Kapua. Today, I'm gonna talk about theorems of infinite limits. So, what are theorems of infinite limits? So, we have here 4 theorems of infinite limits. The theorem number 1, the theorem number 2, the theorem number 3, the theorem number 4. So let's find out the theorem number 1. So I'm gonna give examples for theorem number 1. So first of all, the instruction for theorem number 1: if the limit approaches to the right, let R be any positive integer, then it is positive infinity. The answer is positive infinity. Any number, if it is even or odd, and it approaches to the right, then it should be positive infinity. Example, this is even, and we are approaching to the right, the answer should be positive infinity. If this is odd, and the limit approaches to the right, then it should be positive infinity. Whatever your number is, it is positive infinity. Not to this one. This limit approaches to the left. This limit approaches to the right. This limit approaches to the left. We know that it approaches to the left when it is negative. Alright? So let me focus that one. If it is negative, it approaches to the left. So the rules here in the limit approaches to the left, the R should be even. If the R is even, then it should be positive infinity. Then if the R or integer is odd, then it should be negative infinity. So in order to understand, I'm gonna give you an example. For theorem number 1. Example number 1. The limit x approaches to 0 to the right, and our given constant So what do you think is the answer? The limit is approaches to the right, and according to the rules, whatever the R is, it should be positive. Our R here is 12. Is 12 even or odd? It is even, but it is nothing because the instruction says the R should be even or odd in order to have positive infinity. So obviously the answer is positive infinity. Example number 2. Limit x approaches to 0 to the left, 10 over x3. So what do you think is the answer? the limit approaches to the left. According to the instruction, if the limit approaches to the left and the r is even, it should be positive. If the r is odd, it should be negative. In this case, the r is odd. So what do you expect is the answer? You're right, it's negative infinity. Now let's proceed to example number 3. The limit so the limit x approaches to 0 to the left is 10 over 16 10 over x raised to the power of 16. So our integer, our r is even. So what is the answer? Let's take a look at our instruction. If r is even, positive infinity. If r is odd, negative infinity. In this case, our r is 16. So, and it approaches to the left. Don't forget, it approaches to the left, huh? So the answer should be positive infinity, because 16 is even, and according to the instruction, if it is even and it approaches to the left, it should be positive infinity. Now let's proceed to theorem number 2. In theorem number 2, if the constant is positive and the g of x approaches to the right, then our answer should be positive infinity. If constant is negative instead of positive and the g of x approaches to the left, then it should be positive infinity. Now, on the other hand, if our constant is positive and the g of x is approaches to the left, then it should be negative infinity. If our constant is negative and the g of x approaches to the right, it should be negative infinity. So I have here my example in order to understand well. So the limit so what do you think is the answer? Our limit approaches to the right, and our constant, if we answer this, our constant is positive and it approaches to the right, then according to the instruction, our constant is positive and the g of x is approach to the right, then it should be positive infinity. So in conclusion, the answer for this is positive infinity. Why? Because our limit approaches to the right and the answer, the constant is positive, then it should be positive infinity. Let's proceed to example number 2. In example number 2, the limit x approaches to 7 to the left So, in order to find a constant, we need to answer it first. So, the answer of this is positive. Our constant is positive. And it approaches to the left. So, if we take a look at our instruction, if the limit approaches to the left and the constant is positive, then the constant is positive, it should be negative infinity. Right? It should be negative infinity because it approaches to the left. And our constant is positive. So what do we expect? It should be negative infinity. So let's proceed to example number 3. Our limit x approaches to 2 to the left. So if we answer this one, we get positive. Then according to the instruction, our limit approaches to the left and our constant is positive. Then it should be negative infinity. It should be negative infinity. Alright. So let's proceed to theorem number 3. In theorem 3. Okay, so let's proceed to theorem number 3. In theorem number 3, if the limit f of x equals to positive negative infinity and limit g of x equals to the constant, then the limit x approaches a, f of x plus g of x is equals to positive or negative infinity. So we have, in order to understand well, I will give you an example. So, example number 1. So, our limit, x approaches to 3 to the right. So, we will answer this. So, the answer of this one is 8/0. What do you think? This is positive infinity or negative infinity? according to the law, if our constant is positive and it approaches to the right, it should be positive infinity. So this is positive infinity. Okay, so let's proceed to theorem number 3. In theorem number 3, if the limit f of x equals to positive negative infinity and limit g of x equals to the constant, then the limit x approaches a, f of x plus g of x is equals to positive or negative infinity. So we have, in order to understand well, I will give you an example. So example number 1. So our limit x approaches to 3 to the right. So we will answer this. So the answer of this one is 8/0. What do you think? This is positive infinity or negative infinity? According to the law, if our constant is positive and it approaches to the right, it should be positive infinity. So this is positive infinity. So next, the answer of this one is 3/5. What do you think is this? Positive or negative? So again, according to the law, this is positive and it approaches to the right. So basically, it's positive infinity. Both are positive infinity. So we will write this one as positive infinity, and this one as positive 3/4. So what is the answer? Positive or negative infinity? So, well, if we add this one, positive, this is a shortcut. Positive plus positive is equals to positive, right? So, we have positive infinity from this one. This is positive infinity. And it's also positive infinity. Then, if we add both, positive plus positive, the answer should be positive. So the answer should be positive infinity. Alright? Because this is positive and this is also positive. The answer should be positive. So so we have here our example number 2. The limit approaches to 2 to the left. So the answer of this one is 12/0. So what do you think? Is it positive or negative? Yes, it's negative because our limit approaches to the left and the constant is positive. So the answer should be negative. Negative infinity. Now here, the answer of this is this. This is positive also, and we approach to the left. So it should be negative. Now, negative infinity minus negative 2/2. And what should be the answer? Negative or positive? This is just basic adding and subtracting negative and positive signs. So what is the answer of negative infinity minus 2/2? So it is negative, because negative minus negative is negative. So we're done with theorem number 3, and let's proceed to theorem number 4. Alright, let's proceed to theorem number 4. In order to answer theorem number 4, we should follow this. Positive infinity, if the limit is positive infinity and the constant is greater than 0. Sorry. So basically they have both positive. So positive times positive, obviously it's positive. Or if in reverse, if the f of x is negative infinity and the constant is less than 0 or negative, then we should get positive infinity. In rule number 2, we should get negative infinity if the limit is negative infinity and the constant is less than 0, meaning the constant should be negative. So basically negative infinity times negative is equals to negative infinity times positive is equals to negative. It's basic multiplication. And the rules, if you remember your grade school, high school days, grade 7, so we discuss the multiplication of signs, if it is negative or positive, or you know what I mean. Or if the limit f of x is positive infinity and the constant is less than 0, so again they have different signs, because this is negative because our constant is less than 0, meaning 0 and below, so it is negative. So positive times negative is negative. So in this case we have negative infinity. I have here examples, and the limit is approaching to the right. As you can see, it's positive. It's approaching to the right. Now our answer is positive infinity. Both are positive infinity. If you remember the theorem number 2, the limit approaching to the right and the constant is positive, then we should get positive infinity. Now blah blah blah, and we have positive infinity. Our f of x and our g of x is 3/5. The constant is greater than 0, meaning it is positive infinity. Now positive times positive, guess what? It's positive. Now in our example number 2, the limit is approaching to the left, and our answer here, our f of x is positive. As we all know, the constant is positive and it approaches to the left. The answer should be positive. Here, our constant is negative. So let me show you. Our constant is negative and the g of x approaching to the left, so we should get positive infinity. I'm sorry, this is positive, Now this is negative because according to the theorem number 2, if our constant is positive and our g of x is approaching to the left, then we should get negative infinity. So our answer is negative 12 over 0. Should be positive because negative 12 over 0. In g of x, the answer is positive because our constant is negative. Our constant is negative and the g of x approaches to the left, so we should get positive. Alright. This is positive and this is negative. Negative times positive. Here, if we write f of x is negative and our g of x is positive, the constant is, this is our constant, the constant is greater than 0, meaning positive, and our f of x is negative infinity, then they both have different sign. They have different sign, I mean. So the answer is negative infinity. So I hope you understand our theorems of infinity, and let's proceed to infinite limits. Okay guys, now let's talk about limits of infinity. The definition, let f be a function defined on C, positive infinity, for some number C constant, the limit f as x increases without bound is L, which written as limit x approaches to positive infinity, f of x equals L. If the values of f of x get closer and closer to 1, and only one number, L, as x becomes larger and larger. So I have here my illustration. Limit f of x is x approaches to positive infinity, was limit x is equal to positive infinity 2x squared over x squared plus 7. Now here in our table, we should see x, if we distribute 0 to the function, the answer is 0. If we distribute 1, then the answer is 1. And so on and so forth, until we can see that the x is approaching, the function is approaching to 2. As you can see here, it approaches to number 2 as we increase the value of x, because x is approaching to positive infinity. So our value is 2. Now in negative infinity, if our limit is approaching to negative infinity, so the x approaches to negative. So as you can see, if we substitute negative 0 is equal to 0, negative 1 is 1, negative 2 is 1.6, negative 3 is 1.8, negative 4 is 1.8882353, negative 5 is 1.9230, and so on and so forth. As you can see in our table, still it approaches to 2. So our answer is 2. As you can see, they both approaches to 2. If we graph this, so you can see here our vertical asymptote, which is x is equals to 2. Now here, it approaches to 2 but never touches the 2. So this is the positive side, the function positive, and our negative. So same lang siya. So hi guys, in order to answer it quickly without using those table, so we need to follow this limit theorem. If r is any positive integer, then it should be 0. The limit x approaches to positive infinity, 1 over x positive integer is always equals to 0. So on with this negative infinity right here. So I'm gonna show you an illustration. Limit x approaches to positive infinity, 1 over x squared, which is this x raised to the power of 2 is positive integer, then it should be 0. This is our example number 1 and example number 2. The limit here, x approaches to positive infinity, then the r is positive 5 or positive integer, then the answer should be 0. So I'm gonna give you an example. Those examples that I show you consists only one term for both numerator and denominator. Now I'm gonna give you an example that consists of two terms for both numerator and denominator. So example number 1. So what do you think is the answer? Here, in order to answer this, two terms of denominator and numerator, we need to find the highest degree of the x. So as we can see, we have both highest degree of the x. The x here in numerator is 1, and the x here the denominator is also 1. So in conclusion, we have the highest degree of 1, x raised to the power of 1. So we need to divide it by the degree. I'm gonna show you. Now let's gonna do it also to this denominator over here, over 2x plus 5. Also, we're gonna divide it also to the highest degree, which is x raised to the power of 1. So next step is we need to cancel out the we need to distribute 4x to the highest degree exponent. So we distribute 4x to the highest degree exponent. Also we distribute negative 3 to the highest exponent. So on with the denominator. So we distribute 4x to the highest degree exponent. So it should be like this: 4x over x, and 3 over x. Now 4x minus x is equals to 0, so we don't need to use this. This is negative, I forgot. And so on with this the denominator. So of course it's positive 5 over x. So the next step is we need to cancel out the number with the denominator and numerator. Example, this one. The fraction are considered as 0. This is considered as 0. So we need to cancel this out. And we have 4 minus 0. And over our denominator is 2 minus 0. So we have 4 over 2, or if we divide this one, we get 2. So our limit is approaches to 2. So in order to understand well, let's proceed to example number 2. Find the limit x approaches to negative infinity to x squared minus x over 4x squared minus 1. So what we did to example number 1, and we also follow. Now, as you know, the first rule is we need to find the highest degree exponent. Now, our highest degree exponent is x cubed. Now, we will use x cubed to distribute to any number in a numerator or the denominator. 2x squared minus x over x cubed over, so on with the denominator, 4x cubed minus 1 over x cubed. Now we will distribute. So we get, in our numerator, we get 2 minus this negative x over x cubed. In our denominator, we get 4, because x cubed minus x cubed is 0. So we get 4 minus 1 over x cubed. So as I said earlier that those number has denominator and numerator, these fractions, these are equal to 0. So let's write it down here. 2 minus 0 over 4 minus 0, and we get 2 over 4, or in other words, we get, wait a minute, I'm using a calculator right now. Is equals to, so let's proceed to example number 2. So I have here limit x approaches to negative infinity. First of all, we're gonna find the highest exponent. So we have here x cubed. So we will divide x cubed to the numerator and denominator. So right here, x cubed divided by now second, we will distribute it. We will distribute x cubed to 2x squared and to negative 5. So on with our denominator. We gonna distribute x cubed to 4x cubed to negative 1. And we should get 2x minus 5 over x cubed. Our denominator will get 4, because x cubed minus x cubed is 0. We should get 2. So here 4x cubed divided by x cubed is equals to 4, and x cubed divided by negative 1, so negative 1 over x cubed. So as what I said, we should cancel out the fractions, so it will become 0. So obviously our answer is 2 over 4. 2 over 4. So our limit approaches to 2 over 4, or 1/2. 1/2 or 0.5. So let's proceed to example number 3. So in example number 3, we have 2x squared minus x plus 5 over 4x cubed minus 1. So we have 3 terms in numerator and denominator. I'm gonna add another one so that we could have 3 terms, you know. So first of all, it's gonna find out the highest degree exponent. So obviously it's x cubed. So let's divide x cubed to the numerator and denominator and distribute them. Over x cubed over our denominator for x cubed minus 1 plus 5 is divided by the highest degree exponent x cubed, and we should get if we distribute 2x squared, we should get 2 over x minus, if we distribute negative x to the x squared, we should get negative 1 over x squared. If we distribute positive 5 to x cubed, I'm sorry for that, x cubed, then we should get positive 5 over x cubed over, and now let's proceed to the denominator. If we distribute 4x cubed to x cubed, we get 4. If we distribute negative 1 to x cubed, we get negative 1. If we distribute negative 1 no, I'm sorry, if we distribute negative 1 to x cubed, we should get negative 1 over x cubed. Now, if we distribute 5 to x cubed, we should get positive 5 over x cubed. Now let's erase those fractions. It will become 0, obviously. Now we have 0 minus 0 plus 0 over 4 minus 0 plus 0, or 0 over 4. 0 over 4. 0 over 4, it's actually 0. So our limit here is approaches to 0 at limit x approaches to negative infinity. So 0 siya sa yung x niya approaches to negative infinity, 0 yung sagot niya. So that's it for today for limits at infinity. So just remember the procedure in order to find the limit at infinity. So instead of using this, we should follow this theorem of infinity so that it would be easy to answer. We don't need to use table like this in order to find the limits at infinity. Alright, So, thank you for watching. I'm James Sierra A. Kapwa, and goodbye.